Hello and welcome to my first ever DjangCon talk. I am Mohamed ElKalioby and today I will be talking about passkeys and how to use them on Django. So let's start by who I am. I'm leading the software development team for Center of Genomic Medicine King Faisal Specialist Hospital and Research Center in Riyadh. I am main contributor of Django MF2, which has been started around 200 times on GitHub and downloaded more than 170,000 times. I am the main contributor to Django Passkeys, which is started more than 100 times in around 6 months. So let's start by why passwords are not enough. I think everyone knows the answer of this question, but let's build a common ground. So passwords can be hacked, passwords can be keylogged by a malware which can snatch username and password like logging on the or log into a website using your own PC or a mobile. It can be phished, like sometimes you get an email that you have a problem when we were renewing your Netflix subscription, so you need to click here to fix the payment issue. When you click here, you find yourself on a website which looks like Netflix, but once you put your information in there, you are giving the information to the attacker so that they can have your username and password, and they are repeatable. Since you are we now have your Netflix account, most probably you can be using the same password on your Facebook or your Twitter account. So we have access to more accounts just because we have access to one password. So what is the security principle to have a secure web application? In general, the user should be identified by something he knows, like a password, something he has, like a key or a card, and something he is, like a biometric. Most of our websites today depends mainly on the password, as they are easy to implement and they are very common to the users and they know how to act with it. The use of a key was available for web applications since 2014 when the Universal Second Factor Protocol was introduced, but the protocol needed the user to buy a specific USB device which acts like a security key, and this security key costs between $25 to $50, which caused that protocol was not widely adopted by the users. And in the same time, we have now mobile phones which have access to our biometrics through the Face ID, iris recognition, and or fingerprints. So there was a question why we cannot use this biometrics to be able to verify our users. So a web authentication protocol was introduced. So the Web Authentication Protocol is extension for the Universal Second Factor Protocol. It allows accessing authenticators which support the client to authenticator protocol. Work started in 2016 and became a working standard in March 2019. It's a product of the FIDO Alliance and it depends on asymmetric encryption with a random challenge. And this enables a passwordless authentication and or a secure second factor method. The authenticators would be responsible for verifying the relaying party, which is the website, so the technology should be a phishing resistant technology. So what are the supported authenticators? Currently, you can use any FIDO2 security key on any browser on any OS, including Android, iOS, or iPadOS. You can use your fingerprint or the PIN code on Windows Hello. You can use your screen unlock pattern, your fingerprint sensor, and or your face iris detection method on Android. You can use your Face ID, Touch ID on both iOS and Mac OS X. So let's see what is the user experience when he tries to register and use such authentication method. So in this demo, we will see how the users can register a device. So he will start by logging to the service by using his username and password. Then he will be enrolling to the new security service. He will say enroll. He will put the device name so that he can refer to it later. He will say start. The browser will ask him to use the device. He will ask that he's going with the platform. Windows Hello can ask him between the fingerprint and the PIN. So I selected the fingerprint. Now, as you can see, we have the device registered on our account. So how the user can now use the created key to authenticate to the service. Here, as we can see in this demo, that rather than the user putting his username and password, he can just fast login, he select his username, he says he put his fingerprint, and he is done. It's done in less than 5 seconds, and this is as one of the most secure ways to log into the web service, like we will see later. So let's see what's happening behind the scene when the user tries to register a new Web OS X device. So it starts when the application requests adding a new Web OS X method. So the server sends the site information, the user information, and a challenge. The browser asks the user to select a device and forward the information to it. The device will prompt the user to verify the request and then generate a key pair. The device will send the public key and the signed challenge back to the browser with the device info. The application sends the info back to the server. The server decrypts the received challenge with the received public key and validates it against the sent challenge at the start of the cycle. Here it worth mentioning that we don't hold any user biometric and there is nothing we know about the user biometric features. So now we know how the registration process works for the user to register his key. So let's see what happened behind the scenes during the authentication of the user so that it can happen so quickly. So it starts by the application requests the login to the service, the server sends a challenge, the browser asks the user to select a device and it forwards the site information and the challenge to the device. The device asks the user to confirm his identity and then validates the site. Once the site is validated, the device will send the encrypted challenge and the device info and the user identity to the browser. The application forwards the information to the server and the server decrypts the received challenge using the saved public key on the device for the user and compare it with the sent challenge. So now let's see how Web OS X is a phishing resistant technology. So here we will assume that there is a phishing attack against the bank.com. The attackers are trying to gain access to the customer accounts to be able to reach their bank accounts and transfer money outside. So they were able to fix the user to use hlebank.com. And in a live man-in-the-middle attack scenario, the attacker will enter the information received on the phishing website on the real thebank.com. And since the username and password are correct, the bank.com will ask the user to confirm his identity using the Web OS X. The attacker will ask the user to confirm his identity, hoping to pick up the credentials so that he can use it on the bank.com. Now, the user will click authorize, then the user will put his fingerprint and or their verification method, but now the authenticator will stop him because currently the current authenticator doesn't have any credential for the bank.com. This will lead to stopping of the whole attack and failure of gaining access to the user account, since the attacker will never be able to confirm his credentials since there is no signage for the authenticator from the bank.com. So, as Web OS X was a very secure technology, why it was not widely adopted by the service providers and by the users? Mainly because it had few challenges, and mainly that the keys were device bounded. So if the user uses an iPhone, an iPad, and a Mac OS, he need to create 3 keys on each device, and this causes the services that they need a fallback method for the users to log in. Because if you has registered your key first on your iPad and now you want to log into your iPhone, you need to use another method like an email verification or an OTP so that the user can log in again. And if the user is going to use the device frequently, they need to register the device. The challenges that affected the Web OS X, what are the things that Passkeys are trying to solve? So let's start by defining what is Passkeys. Passkeys is a work between Apple, Microsoft, and Google to expand the support of FIDO standard to accelerate the availability of passwordless sign-in. It is all started when Apple open the support for passkeys in iOS 16, iPad 16.1, and Mac OS Ventura, allowing the user to sync the private keys on their keychains. On May 3, 2003, Google allowed the users to stop using their password to log into their Google accounts and start using passkeys instead. So what is passkeys all about? It's a way for the user to use a key stored on another device to log in or to the service. The user can ask a nearby device to sign the request on their behalf. Keys can be used on the application's website and mobile application, and preferably the keys should be syncable between devices. So what is the current state of passkeys? Currently, Apple stores a private key generated on any device on the iCloud keychain protected by a PIN and is synced to all devices. Google stores all private keys generated on Android on your Google Password Manager. On Windows, keys are stored on TPM, and on Chrome on Mac OS X stores the key on the device. Safari and Chromium-based browsers can ask iOS/Android devices to sign the requests through BLE. On Android and iOS, keys can be shared between the app and the web application. Passwords vaults are now evolving to be passkeys vaults. Firefox doesn't support passkeys but supports Web OS X. So how can we integrate this very nice technology to our current web applications, protecting our users and our data? So Django Passkeys is an authentication backend for passkeys. It is easy to integrate in your current authentication flow, includes the interface for the users to manage their passkeys, allow knowing if the user is using passkey or not, allow knowing if the user is using a passkey from another platform, works with the Django 2.0 Plus and Python 3.7 Plus, and is get downloaded around 2,000 times a month. So how to add passkeys to your Django app? First, you need to install it using pip install Django keys. Then you add passkeys to your installed apps, collect the static files, then you have to do the database migrations. Then you need to add the volunteer settings file. You need to modify your authentication backend to be passkeys.backend.passkeys model backend. Then you need to provide the domain where your website is hosted. Then you need to provide the server name, which is like a user-friendly name for the website to be identified on the authenticator. Next, you need to identify which type of authenticators you are going to use. Are you going to use roaming authenticators, which is like cross-platform authenticators like security keys as they roam between devices, or you want to use the platform authenticators like the Touch ID and Windows Hello. Then you need to add the passkeys to URL patterns. Now, in the login view, we need to change the call to the authenticate to have the request as the first parameter to be able to see what's inside it. Next, in the login template, we need to add an hidden input called passkeys to be able to hold the result of the passkey to the hold of the passkey authentication, and we need to give an ID for the form to be able to auto submit it once the passkeys results is available. Finally, we need to add a link somewhere for the user to be able to manage their keys by referring to the passkeys home. And you are done. So let's see passkeys in action. On the left, we have an iPad which doesn't have the passkey to use for the secure service, and on the right is my Android phone. It has the key registered as we registered it in the first demo. So now we will try to use them. So on the iPad, we will just say fast login. The iPad will ask me which device to use. I will select the iPhone or the Android device. It will give me a QR code. And now we will take the Android phone and we'll try to scan the QR code and using the camera of the Android. So now we scan the code, we open the link. Now it asks me to verify the connection request, and now they are trying to connect together. Once they are connected, the Android phone will ask me to verify myself. I verify myself, I put my fingerprint, and now the iOS was able to log in securely to the service using the PKey account. So if you don't need to host your own passkeys and you want a simpler solution, or if you are using a mobile application, I recommend that you use a passkey as a service like JustPass.me. JustPass.me is a FIDO2 and OpenID certified service. They allow having passkey on web applications and mobile application on both iOS and Android. Users can log in by passkeys or social or email if allowed by the site. They have Django, Flutter Firebase authentication plugins, and they are free up to 1,000 free monthly active users. So in conclusion, we discussed why passwords aren't enough, what is Web OS X API and how is it phishing resistant, what were the challenges in web authentication and how passkeys solved it, the state of passkeys, how to integrate passkeys in your Django application. So I will be available on Twitter, GitHub, or the conference Slack for any questions. Thank you.